Hi guys, this is Vineet and I welcome you to this video. Today's video topic is how you can access the file stream data with Transact-SQL in SQL Server. We will demonstrate you practically how to do this. Guys, if you are new to this channel or if you haven't yet subscribed to the channel, please go ahead and do so. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. The reason I'm telling you to subscribe is because I don't want you to miss any of the videos that I'm creating on FileStream these days. And these are a series of this is a video series on FileStream. So I don't want you to miss any single video on this topic. Otherwise, you will be out of sync. So it's very much essential that you should subscribe. So let me give you 5 seconds to subscribe immediately. I'm waiting. Please subscribe right now. So guys, I hope you must have subscribed by now, so we can move ahead now. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your lab and test environments only. Do not touch any production environment or production databases. And we would like to know your thoughts regarding our videos, so please do share in comments, feedback, reviews, suggestions, requirements, questions, and you may let us know about your day-to-day experiences with SQL Server. And you may also let us know your stories about how my content has helped you some way or in some situation in some way. So do post in your comments and stories, guys. We love to read them and we eagerly wait for the same. All right, let's move ahead. We have created some playlists for you to watch. This video belongs to the SQL Server database design playlist category, and this category has more than 85 videos at present. So I will keep on adding videos to this category and to other categories as well. Some of the other categories are SQL Server tables, business continuity, SQL Server indexing, performance tuning, integration services, Transact-SQL. And we have a new series on Python programming workshop as well, which we have just started, and it contains a couple of videos. If we talk about the total number of videos posted on our channel, it's more than 230 videos. Guys, the reason why we create playlists for you is because we feel that playlists are best way to learn about any particular domain. So for example, if you want to learn about the SQL Server database design domain, what we would suggest is go to the SQL Server database design playlist and watch out all the videos from starting till the end. And the links to these playlists and my channel page link is given in the video description area of this video. So please check out the video description area to get all the links, and you may visit each link for any of the playlist and for my channel page as well. Now let's come back to today's topic, which is how you can access the file stream data with Transact-SQL in SQL Server. So let me take you to SQL Server directly, as this will be a practical video. So let's connect to the default instance of SQL Server. And in this demo, we will describe how to use the Transact-SQL insert, update, and delete statements to manage the file stream data, how you can work with these statements, insert, update, and delete, to manage any of the file stream data. And the prerequisite to this demo is that you should have a file stream enabled database and a table. I hope you have watched the previous 2 videos of this series. If not, I would highly recommend please go through them. Otherwise, you won't be able to complete this practical. Please watch the previous 2 videos where we have taught about how you can create a file stream enabled database and how you can create a table with a file stream column. Complete those videos first and before continuing with this video. Now let me move ahead. We have a file stream enabled database we had created earlier, which is archive database, and under that we have a file stream enabled table, and the name of the table is db.records. Now what we will do, we will insert a row that contains file stream data, and to add a row to a table that supports file stream data, we use the Transact-SQL insert statement. And when we insert data into the file stream column, you can insert null or a var binary max value. So if we talk about this table has this column, chart column, as a file stream column containing the var binary max data. Alright guys, so this chart column is a var binary max column and it can have null values, and it's a file stream column here. Alright, so in this column we can either insert the null value or a var binary max value. Now let's talk about inserting nulls, and we will cover an example here. So let's trigger a query against this database. In this example we will show you how to insert null. When the file stream value is null, the database engine doesn't create a file in the file system. So whenever we put a null value into this column, which is a file stream column, or when the file stream value is null, the database engine doesn't create a file in the system. So let's insert a value into this table. So let's insert into archive is the database, DB is the schema, and records is the table. Let's insert into this table values for the first column ID, which is a unique identifier that cannot be null. Let's generate a new ID using the new ID function. And for second column, serial number I'm taking as 1, which is integer null type. And for third column, which is chart, which is a file stream column, I'm taking null as the value. Let's execute this statement to insert a null record into this table. So we can check the data of this table right now. So we can do select star from this table to see what data row is inserted. Let's run this statement. So we have a new ID generated using the new ID function. Serial number is 1, and in the chart column, which is a file stream column, we have inserted a null value. Now what we can let's do the next practical where we will insert a zero length record. So first example we have covered here is we have covered inserting a null value in the file stream column. This was the first practical. Now in my second practical, what I'm doing is I'm inserting a zero length record or an empty string, you can say, into the file stream column. So the following example will show you how to use the insert statement to create a zero length record. And this is basically useful for when you want to obtain a file handle, but will be manipulating the file by using the Win32 APIs. So basically this is inserting the zero length record is useful in the situation where we want to obtain a file handle using the Win32 APIs whenever we are manipulating a file by using the Win32 APIs. So let me just show you how to insert a null value. So let's insert into archive.dbo.records table and values. Let's insert a new ID using the new ID function. Alright, and this function basically generates a GUID. Let's add 2 as the serial number, and let's add an empty string as the var binary max value, because this column cannot contain a string, but instead of var binary max column. So we need to explicitly cast the empty value into a var binary max value. So let me show you how to do this. So you need to use the cast function, and what you're putting is you're putting null, and we need to cast this null as the var binary max type. So casting is done, and one extra bracket is required for values. So I've put that bracket here. Now this is complete, and we can execute it to insert a null record into a file stream column or var binary max column. I've inserted the second row. Now let's check the records. We have 2 records. This is the one we have recently inserted. Now we have inserted an empty string and converted that string into that var binary max. So it is stored as 0x as a hexadecimal value, as a binary hexadecimal value. So this is how the data gets stored in the chart column. So we need to explicitly convert any data into the var binary max type before we can insert the data into the file stream column. Now let's create a data file. This is the third demo here, where we'll create a data file. Now this example will show you how to use the insert statement to create a file that contains the data. and the database engine converts the string. We will take some string here to a var binary max value, and FILESTREAM creates a Windows file. If it doesn't already exist, the data is then added to the file. So here we are showing you how the SQL Server database engine creates a database file using an example. Now let's insert into the same table archive.dbo.records. Let's insert values. Let's generate a new ID using the new ID function, and let's create the third row with the third serial number, and let's close the values bracket. And now we need to explicitly cast some value from taking a string data. Let's take seismic data, and let's convert this value seismic data, which is a string, into var binary max. We need to do this conversion because in case we want to store this data. So this is done now. This function is complete, and basically what this will do, and this will, as we are storing some data here, not a null value. So what this insert statement will do, the database engine will convert the string seismic data, this string, into a var binary max value here because we are using some explicit casting. And in this case, FILESTREAM creates a Windows file if it doesn't already exist. The data is then added to that particular data file. Alright, so in this case, FILESTREAM will create a file and it will add this data to that particular file. Alright, so let's execute this statement. So we have inserted this row. Now when you select the data from the archive DBO records table, so let's see what do we get. So the third row is also inserted. This is the new ID for that. Serial number we have posted as 3 here. And we have stored this seismic data and converted into var binary max, or a binary data, converted this character values into var binary max data. So this hexadecimal value is stored in that particular column. Let's move ahead. So this is how we store the data into the var binary max column and string data by converting it into the var binary max form or type. Let's say if we have any files created. So we had allocated a folder C drive data for this file creation where we have FILESTREAM. So we see over here 4832 GUID ending in 4832, and in SQL Server these IDs are separate, right? So these are not associated. But yeah, we see some files are created. I don't know how it is using that file. But yeah, later on we will show you uh, what can be done regarding these files. But for now, let's leave that. So basically, this is the same string seismic data stored in the hexadecimal format. This is what I wanted to show you. Now, let's move on to how you can update the FILESTREAM data. This is the next demo, how to update the FILESTREAM data. Let's cover this practical. So you need to use the update statement to update any data. Use update, give the table name, archive.dbo.record. This is the table name. And let's set the chart column, which is a var binary max column or a FILESTREAM column. We need to do casting because in order to update any values, we also need to do the cast function. Let's update the value from seismic data to x-ray 1. So this is the value we want to store in a chart column, and let's convert this data into var binary max type. All right, and this bracket is not required, and where we are taking serial number as 2. So we are updating the second row over here, which currently has null value stored in the chart column. We are storing x-ray 1 into that column. So this is how you update the data. You basically need to do use the cast function. That is what is unique about storing the var binary max data. You need to do some explicit conversions. Now let's execute this statement. Now this second row is must be updated. Now let's select the data. We see now the second serial number row contains the x-ray 1 converted as var binary max and stored in the hexadecimal form over here. Now let me show you another practical how you can delete the FILESTREAM data. So we will delete the FILESTREAM data. How to do that? Let me first talk about it. When you delete a row, that contains a file stream field. So for example, if we delete any of the rows and it contains the file stream field, we also delete its underlying file system files. So whenever a row is inserted, its associated file system files are also get deleted. The only way to delete a row and therefore the file is to use the Transact-SQL delete statement. So the only way the actual physical system file gets deleted is to delete a row from the table using the Transact-SQL delete statements. Now let me share an example how you can delete the data from data from a table containing a file stream field. Now delete, specify the table name, which is archive.db.records. We are deleting record where the serial number is 1. So let's define serial number is 1. And let's execute this statement. This statement will delete the first record having null value for the chart column. So let's execute this statement. This statement is executed. And if we select records, now we will only have 2 records with the serial number 2 and 3 at present in this file. So when we select all the data from the archive DB records table, the first row is gone and we can no longer use the associated files related to that first row. And the underlying files are removed by the file stream garbage collector, which is a process. Whenever you delete a row, the file stream garbage collector process runs and will remove any underlying files. Now let's do an example. Let me do that in a new query window. So here we will perform a practical. We will check whether a table or files, or I can say database, contains any file stream data. How you can perform these checks, whether a particular table contains any file stream data or a database contains any file stream data, how to perform these checks. And basically to find out whether a table or a database contains the file stream data, you must query some of the system catalog views. And we are currently demonstrating you an example which shows the steps to create a new database altogether. So we will not be using this archive database. We will create a new database altogether. We will create new tables which will have file stream data. And we will query the system catalog views to see whether the tables and the database itself contains the file stream data. So this will be a lengthy code. So you may write that along with me right away. First of all, we should be in the master database, and let's create a new database from here. So create a database. The database name here will be FILESTREAM test. This is our database name. Let's take containment as none for this database. So this is not a contained database. And let's, on the primary file group, we want to create certain files. So let's create a file on the primary file group. The logical name of this file will be name equal to, let's take FILESTREAM test as the name. This is the logical name. Now let me define the physical file name. So let's give the physical file name over here. And I'm using here for any Unicode characters. So to pass any string with the Unicode characters, we use the n prior to that string starting point. Let's give the location for the this database file, primary database file. Our data gets so let's go to C drive, program files, and Microsoft SQL Server. And under that we have Microsoft SQL Server 16 MySQL Server. Go to MySQL Server folder, and under that we have data folder. So where we will find all the MDF and the LDF files. Let's copy out this location. I want to create this file here. So copy that location out, and name of our file will be FILESTREAM test.mdf. I'm giving this file this particular name. And after that, you need to post in comma. And let's go ahead with the next field. So next field is, let's define the size of this file. Let's take this file as 204,800 KB. This is the file size. Next column is max size. Let's define the max size as unlimited. The file can grow unlimited. There are no restrictions on the max size. And let's provide the file growth parameter, how the file should grow. So it should grow by 65536 KB. Whenever the file gets full, it should grow by. 65536 KB until it consumes all the space on the drive, because max size is unlimited. So primary file description is done. Now let's create a so this is primary file description. Now let's put a comma. Let's define the file group for this database, and let's define file stream file group. Let's give it a name, file stream file group. It basically contains file stream. It will contain file stream data, and let's specify the default here. So let's take name, the logical name of this file as only the logical file name exists, not the physical file name, because file stream we do not provide the physical file name for file streams. We just provide the logical file names. File stream test file stream as the name, and for file name let's put, so for physical file name we just provide the folder name, not the complete file name. So for physical file name, what we'll give is, let's put that location data, and we just provide the directory name, and this directory should not exist prior to we are creating it. So let's specify the container name of the directory name. It's file system file stream test fs file stream. This is the directory name, and let's specify the max size now for this file, and I'm setting it to unlimited, and I'm closing it here. Let's create log of this database from, let me see how log has to be created. Let's start the log description over here, and let's provide the logical name for the log file. So the name for the logical name for the log file will be, let's take that name as file stream test log as the file name. This is the logical file name. Let's put a physical file name over here, and we need to specify the location, and the file name will be here is file stream test underscore log will be the file name, and LDF is the extension for log files. So this is done, and put a comma in the end, and file name is specified. Let's specify the size and the max size parameters. So let's take size as 270336 KB, and take the max size as let's take it as MB, so that should be good. Let's see what happens if we take this file size. Now let's take file growth parameter. So let's set the file growth. This file should increase by 65536 KB, and this max size is 2 gigabytes. 2048 MB is around 2 gigabytes, so that should be sufficient for now. Let's create it with these parameters, and all right. Now we have defined all the three files. We have defined the file stream file, and we have defined the primary data file, and we have defined the log file for this database. Let's take the catalog collation. We can define catalog collation to be similar as the database collation. All right. So any tables will have the same collation as the database default collation. All right. So let's execute this statement to create this database first. So this database is created, guys. Now let me run some commands after this. Let's create a new query window. Let's try to use that database, newly created database. So let's refresh the database list. We will get our database. So new database name is FILESTREAM test is our database. Now we will create a table under this FILESTREAM test. So we can select the FILESTREAM test from the drop-down list. So let's select FILESTREAM test, and let's create a table. Table name is FSTIFFS. Let's take this table. Let's define this table. Some columns. So first column is column name is the GUID. GUID is the name of the column, and it should be a unique identifier column, and it will be a row GUID column. It will not be a null, and it must contain the unique values. And the default value for this column will be, let's generate a new sequential ID using the new sequential ID function. All right. So if we don't provide any value for this column, it will automatically generate a new sequential ID using the new sequential ID function. Now let me define the next column. which will be document ID column, and it will be of integer type and it will not contain any nulls. Let's take document type column, and this will be a varchar type column which defines the document type, and will also not be a null column. And let's take a next column which will be a file content column, and this column will be a var binary next column or a file stream column, and we need to specify file stream along with it in order to indicate to SQL Server that it's a file stream column. And the last, let's take date inserted as the column, and this will contain a date time data type, and no restrictions are defined for this column. Now let's create this table quickly. So this table is created. Now let's move ahead, and this table contains a file stream column. Now we will run some queries to figure out which database and files use FileStream. So this is what we basically wanted to check, which database and files use the FileStream data. Now you can run a following query. First, let's select star from there is a system catalog view which you can query. So sys.masterfiles is the system catalog view which you can query. We can specifically filter it out on the type description. In that we can specify file stream. So it will give us any rows for the files which contains the file stream data. So let's execute this. So there are 3 database IDs that contains the file stream data. It has listed out the details. So we got 3 database IDs which are basically using the file stream data. All right. And we can take a set of specific columns instead of star. We don't want to use all the columns. So let's create a DB name using the DB name function, and to this function we can provide the database ID as the argument to create to show us the database name for that particular database ID. Let's take second column as name as file name. There's a file name column, and let's take physical name as the physical file name. And let's take the type description, which we are just selecting as file stream. And after that, we can take any of the columns. After that, let's execute this statement. So the first 4 columns will be the one we specified. Let's execute it. So we got the database name. So worldwide importers is using the file stream data, and the details of the file. This file name is given, which is basically the container name, not the actual file name. And this is the location of the physical file name, which is this particular container. Worldwide importers in memory data underscore 1. And second database is the archive database, which uses the file stream data. And the container name is arc3. The container name is file stream 1, but the file name, the logical file name is arc3. These are the logical file names, and these are the actually container names. And the third database we have just created right now is the file stream test. And this is the logical file name which we had created here. So this is the logical file name, right? No, this is the logical file name for the file stream data file. All right, so this is the logical file name, and this is the container name under which we are storing the file stream data. So guys, you got the idea how to use the system catalog view sys.masterfile to get the rows for any of the databases that are using the file stream data. You can use this query. Now let me show you the query to figure out which tables in the database have file stream enabled. So here we are taking a particular database. So let's check inside the file stream test database to see which particular tables are using the file stream data. Here only we have one table which is using the file stream data. But yeah, if you want to check how many out of 100 tables are using the file stream data, you can follow the following steps. So let's select star from the system catalog view, systables. So systables is the system catalog view. And the criteria we specified to get the file stream column type is, we can specify the where condition. And we have a column name file stream data space ID. And this should not be null for any tables. containing the FILESTREAM data. All right. So let's execute this statement to get this data. So when we ran this command, we got this table. FSTIFs is the table name, which contains it's a user table and it contains the FILESTREAM data. So guys, let me now show you how you can insert a JPEG file into this particular database, a table, FSTIFs. Now, let me take you through another demo. Insert a JPEG file into the table. So guys, we have taken some files into the C drive temp directory. Now, one file is sample1, which is the following graphic. It contains the word JPEG, and the second sample is the sunflower picture, which we'll store. Now, let's try to use this samples to insert the row into FSTIFs table. And in order to insert the row, we will do insert into FSTIFs. And let's specify the columns we want to insert. So the document ID is the first column, document type is the second column, and the third column is the file content, and the fourth column is the date inserted. So these are the columns I am inserting the data into. Now the data which I want to insert is, let's select the data. I'm selecting 101 for the document ID. Let's select the document type as .jpg because we are storing the JPG file. So let's select JPG as the document type. And for file content, what we are doing is we are taking all the file contents. All right. And for the date inserted functions, let's take a get date function to generate the dates inserted. And I'm selecting this data over from an open row set function. Let's use the bulk keyword and specify the file name from which we want to get the data. So we are using the sample file one over here. We will use this one. So let's specify the path. So it's C drive sample one.jpg is the extension, I think. Let me reconfirm. So it's showing JPG is the extension. So yeah, that's okay. So let's select JPG as the extension. And I want to read this file as a single block. So specify it as single block. All right. And let's take this as RS. The name for this is RS, Rosa. Now let's insert this data quickly into the FSTIFs table. The data is inserted. Now let's select star from the FSTIFs table. Let's see what do we get. So one row is inserted. Document ID we have specified as 101. Document type is .jpg. And the file content is this hexadecimal value, and the date inserted function is there. All right, and we use the open row set function to insert data from a particular file. So we have taken this JPEG file, and this is the command structure you need to follow. We will talk about open row set function later. I don't want to get into details. Basically, this one is used to read from the files. And now let's update this document. Let's try to update this document sample1 with the sample2 over here, which is the sunflower picture, different from the first sample, which just the JPG name. Now we will change the document to document sample2.jpg. Let me show you how to do that. So we will do update the FS tips table, and we are setting the file content. So this is the column I'm changing. All right, and I need to use the row set function, open row set function once again to set the content of this column. So we can do select star from open row set. This is the function, and we need to specify the bulk keyword along with the name of the file. So it will be C drive temp sample2 this time, sample2.jpg file we want to use instead of the sample1 JPG used earlier. And we want to read this value as a single blob. All right. And we are taking this row set as RS as the abbreviation for this row set. Yeah, this is how you update the table. And in order to, you should specify a filter as well. So if you want to update it for one row, let's specify the document ID as 101 for this particular row. so that it should update only this particular row with document ID 101. So providing a filter is essential whenever you use the update statement. That's the general concept of while using the update statement. All right, let's execute this statement. So this statement will update the document content or the file content column. Let's execute this. So this is done now. All right, and now let me tell you how to delete the document. Delete a document. Now we delete from the FS table where the document ID, let's take it as 101. Let's delete that row. Whatever row we have created, there's only a single row which we are deleting. So that row is deleted. Now let's clean up any delete files. So in order to perform any cleanup of the actual files on the file system, we can execute the stored procedure. To clean up any delete files, we will execute the stored procedure. And the stored procedure is SP FILESTREAM force garbage collection. We need to use the stored procedure. And we need to provide the DB name parameter, which we are taking as the database name. The database name is FILESTREAM test. It's the database name. We want to perform a garbage collection against this database. So we are executing the stored procedure garbage collection against this database FILESTREAM test. All right. And the second parameter I need to provide is the file name for which we want to do the garbage collection. Let's take file name as, so what was the file name? We need to provide the logical file name over here, which was, what was the logical file name? It was this one, FILESTREAM test. FILESTREAM is the logical file name. So let's provide that here. So this is the complete set of arguments. We can execute this statement to perform any garbage collection. I have executed this. So it is saying that number of collected items is 0, number marked for collection item is 0, number of unprocessed items is 2. So it has not deleted the actual files as of now. So it is showing number of unprocessed items as 2. For somehow it has not deleted the files, although we had deleted the row. So it should have deleted the files, but somehow it has not deleted. But yeah, generally we use this stored procedure to perform any deletion stuff. So we can ignore this for now. We will talk about this stored procedure later on, how this works and why the files were not deleted. Ideally, it should have deleted the files, but it has not, as it is showing the number 2 items under the number of unprocessed items. I'm not sure whether it talks about the actual physical file here or the data in the files that get created in the data folder for this container. So that container altogether does not exist here right now. We can reinsert the data as well if you want. So if we do select star from FSTIFs, let's see if it contains anything. No, it does not contain anything. Let's try to insert a JPEG file once again. Sample one. Let's execute this. And we have a column here as well. Let's see if there are any changes over here. I don't see any changes over here. And if we talk about the file, so file stream data container gets created in the this directory. I need to go there. It's not in the C data. This is the container for this file stream data. Let's give the permission to continue. So under that we have multiple folders right away, right? And this is the, let's see what happens if we see any changes after deletion. So we have inserted one row with sample one, and right now it is showing us this one particular row. Let's update the document to sample two, and let's select the data. So we still have one row. Now let's finally delete the document. Let's see if there are any changes to a file system here. FS log contains these 11 items, and this particular GUID folder contains the 4 items, right? Now let's delete the FSTIF document ID 101 and let's perform the garbage collection quickly. So let's see. Now it is showing the number of unprocessed items as 4. It has not processed those items. No difference here. Right, and under the FS log as well, we have 11 items, sorry. So let's see. Now it is showing the number of unprocessed items as 4. It has not processed those items. No difference here. Right, and under the FS log as well, we have 11 items, sorry. There are no actual physical files deleted in terms of temp folder and the actual files in the container as well. We don't see any actual physical file deletions happened. So we will talk about it later in much more detail. For now, just assume that this particular stored procedure does the work of garbage collection. So it has marked those items as unprocessed. It has got that it has found that it has 4 files to delete, but it has not deleted those files, maybe due to permissions issue or something. Let's execute this again to see. It is giving me the same result. It is not deleting the actual files. So let's leave that for now. And guys, we are done with this video. I hope you like this video. In this video, we have discussed about how you can access the file stream data with the Transact-SQL. We have shown you how you can insert a null value into a table containing a var binary max column, or you can insert a zero length record into a table containing a file stream column, and how you can how you can insert a data with the data row with the textual data or string data in a table with the file stream column. And we talked about how you can update the file stream data. Finally, we talked about how you can delete the file stream data. And we have shown you a complete new example where we have created a database with the file streaming enabled with a file stream file group. And we have created a table with the file stream column. And basically, we have shown you how you can query the system catalog view sys.master files to check on any of the databases that are file stream enabled by using the filter where type description type equal to file stream. And we have shown you how you can you can query the system catalog view sys.tables to get the idea on which tables have the file stream data space ID column as not null to indicate that it contains the file stream data. Finally, we uh, to inserted a JPEG file into a table as the document or as the file content using the open row set function. Then we updated that file content column again using the open row set function by using a different file. And finally, we deleted that particular row or record. And finally, we executed the garbage collection procedure to remove the actual physical files from the system, although it has not deleted the file, so we can troubleshoot on that later. But yeah, we have just shown you the procedure to give you an idea. We use this stored procedure to perform any garbage collection for any of the deleted files or records, associated records. So guys, we are done with this video. I hope you like this video. If you really like this video, please click on the like button which is below this video. And guys, if you are new to this channel or if you haven't subscribed to this channel, I would highly recommend instead to go ahead and subscribe to this channel right away. There's a subscribe button below this video. Click on that subscribe button. It will give a bell icon. Click on that bell icon. Select all notifications to get notifications regarding all my future videos. The reason I'm telling you to subscribe is because we will be creating more videos on FileStream, which I don't want you to miss any of the videos if you want to gain better understanding on how to deal with the FileStream data or the blob data. And in my next video, what I will cover is I will show you how you can create a client application in the language of your choice, maybe C script or C sharp. Maybe you can use VB or C++ to basically we will use these languages to basically create a client application for the file stream data. And I will show you where I will show you the application code to use the file stream data. And that will be highly useful practical. And in next video, I will try to discuss the best practices for application design and implementation as well, but may cover that in another video. This will be our stuff for the next video, so I don't want you to miss on that stuff, and I want you to get timely notifications regarding any of the video I upload to the YouTube. So please do subscribe. If you haven't subscribed, please go ahead and do so. I'm giving you 5 seconds. Please go ahead and do so right away. So guys, I hope you have subscribed by now. Also, guys, do post in your comments, feedbacks, reviews, suggestions, requirements, and questions, any day-to-day experiences with SQL Server. You may let us know about the situations where my content has helped you somewhere in some way. Do post us your comments and stories as we eagerly wait for the same and would love to read your stories and comments. And also, guys, if you have a good network of friends who are working in SQL Server domain, please ask them to join my channel as I post really useful video content or on SQL Server. So I post a really best SQL Server content on the channel, which will be useful for them. So do ask your friends to subscribe to my channel. You can also share my videos with your friends. There's a share button below this video through which you can share my videos, YouTube videos on the various social media platforms. Make use of that link to share my videos. Guys, I thank you so much for your time on this video today, and you have a wonderful day ahead.